awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Alright, question 7a. So here we have 2 marks. So 3 meter length of wire of diameter 0.4 millimeter is fixed to the ceiling when a 0.5 kg mass is suspended from the bottom of the wire. It extends by 0.9 millimeter. So calculate the value of Young modulus for this wire. So means that here, let's say we have a wire. Okay, so you need to calculate what is the cross-sectional area of the wire. Okay, so let's say this is the ceiling, and then when we have a mass, okay, we put a mass here. Okay, so means that the force exerted on the cross-sectional area here is equal to the weight of the mass. So it should be equal to mg, which is the weight of the mass. So means that the force that we put, or the force exerted on the cross-sectional area of the wire, is equal to, so 0.5 kg, okay, that one 0.5 kg times 9.81. So F here is equal to 4.905 Newton. Jadi bila kita letakkan mass 0.5 kg pada wire tu tadi, apa yang berlaku, dia cakap wire itu akan extend sebanyak 0.9 millimeter. So X is equal to, so means that this is the final length. So this is the elongation ataupun pemanjangan tadilah. X equal to 0.9 millimeter. Okay, so we want to calculate what is the Young modulus. So remember, Young modulus is equal to stress over strain. Okay, so dekat depan dia dah bagi dah equation untuk stress is force over the cross-sectional area, and then strain is delta L over L naught. Okay, so kalau kita susun semula, okay, kita akan dapat lah, okay, Young modulus is equal to F L naught over A times delta L. Okay, jadi saya nak tekankan dekat sini untuk kira ni, okay, cross-sectional area, sebab soalan bagi diameter, okay, of the wire is 0.4 millimeter. So bila you kira asing pun boleh lah, the cross-sectional area which is pi r squared. So ramai pelajar bila r tu dia terus masukkan pi, diameter tu dia bagi 2, d over 2 squared. Bila you squared, pastikan you kira betul-betul pi d squared over 4. Ini ramai yang careless lah. Pi d squared over 4, bukan pi d squared over 2. Okay, jadi area ni pastikan awak kira dengan betul. Jadi sekarang bila kita nak kira Young modulus, so we can substitute the value here, where y is equal to F tadi kita dah kira 4.905, and then L naught is 3 meter. Okay, ni soalan dah bagi tadi, over the cross-sectional area is pi d, the diameter is 0.4 millimeter. Okay, milli adalah negative 3, squared jangan tertinggal, over 4. Jadi kalau you nak kira area ni, you nak kira asing pun sebenarnya lebih bagus lah. Okay, supaya mengelakkan kesilapan. Okay, jadi you kira asing and then you masukkan saja dalam equation pun lebih baik. And then delta L tadi, iaitu dia punya extension ataupun elongation. So kita dah tahu dia bagi tadi 0.9 millimeter. So make sure milli is power of negative 3, bukan power of negative 2. Alright, so you tekan kalkulator elok-elok, you akan dapat Young modulus. Pastikan unit Young modulus tu ingat 1.3 times 10 power of 11 Newton per meter squared. Okay, so this is the answer for 7A. Alright, now let's continue 7B. So here we have the wall of a house is 7 meter wide and 6 meter high and is made from 0.3 meter thick brick with thermal conductivity of 0.6. Alright, and then the surface temperature on the inside of the wall is 18 degrees Celsius and that on the outside is 8 degrees Celsius. Assume the heat loss through its side is negligible when a steady state is achieved. So sketch a temperature against thickness of the wall. So we want to calculate a graph of temperature against the thickness of the wall. So before that, so let's try to sketch the wall of a house. So means that the width is 7 meter and then the height is 6 meter. Okay, so means that this is the height and this is the width of the wall. Okay, so this is 7 meter and this is 6 meter. And then it's made from 0.3 meter thick brick. So we consider this is the thickness. Okay, so means that the thickness here is 3 meter. So the height is 6 meter and then given that the inside temperature is 18 degrees Celsius. So let's say this is the one side 18 degrees Celsius and this is another side. Okay, 8 degrees Celsius. Okay, 8 degrees Celsius tu this one lah. Yang kali kuning ni kat sini. Alright, so now let's try to sketch a graph. Temperature, which is T. So temperature, the unit is degrees Celsius. And then the thickness. Okay, so the thickness you can put X or you can just write thickness. So it is in meter. So from 0 to 0.3. And then the temperature, okay, the higher temperature is 18 degrees Celsius. Okay, so it should be here and then here should be 8. Okay, so start from 0, the thickness, okay, the end of the thickness is 0.3. So maknanya dekat 0.3 thickness tadi adalah dia punya suhu 8 degrees Celsius. While this one should be start, okay, from here lah, dari sini ke sini. Okay, so kita straight line graph macam tu. Okay, you can show. So the straight line graph showing you that the temperature will decrease. Okay, and then B, calculate the amount of heat that flows out through the wall in 1 day. So 1 day tu maksud dia masa dia 24 hours lah. Okay, so 24 hours. So 24 hours we change to second. So 1 hour is 60 minutes. Okay, and then 1 minute is equal to 60 second. Okay, so kita kira lah. So 1 day, okay, is equal to 24. So 1 day, so actually 1 day is equal to 24 times 60 times 60 second. Okay, awak kira lah tu berapa. Boleh Alright, so we want to calculate the amount of heat, bukan the rate of heat transfer. The amount of heat means that we want to calculate Q. So kita boleh guna formula Q over T yang dah diberi dekat depan tu, negatif KA delta T over L. Okay? So jadi soalan bukan minta kita cari Q over T. Soalan minta kita cari Q. So finally we can write that Q is equal to negative K. K tadi dia dah bagi ke? Berapa dia bagi ke atas tadi? 0.6 So K is 0.6 and then the cross-sectional area, okay? So the cross-sectional area, tengok balik dekat gambar yang kita lukis ni, inilah. Okay, which is this is the cross-sectional area 6 times 7 meter. Okay, so it should be 6 times 7. And then delta T final should be lower temperature 8 minus 18 degrees Celsius over L is the thickness. So the thickness is 0.3, right? Not 3 meter, sorry. 0.3. Yeah, 0.3, sorry. Dekat gambar ni saya letak 3 meter Sebenarnya 0.3. Saya tersilap tulis tadi. Jadi dekat sini adalah 0.3 meter. Okay, so kita masuk kat sini 0.3. And then multiply the times. Okay, which is 24 hours times 60 minutes times 60 second. Okay, so masanya adalah sehari kan dia kata. So 24 times 60 times 60. And finally, the answer is equal to 7.26 times 10 power of 7 joule. Okay, so this is the answer for question 7B2. Okay, so now let's proceed to question 7C. So now question C, at 35 degrees Celsius, the area of a sheet of aluminium is 30 centimeter squared. So ini adalah perangkap dia lah. The cross-sectional area is given in centimeter squared. Make sure you know how to change the unit, centimeter squared to meter squared. So the coefficient of linear expansion means that alpha is given. Alright, determine the final temperature if the final area is 30.2 centimeter squared. So this is A final and this is A initial. So we want to calculate what is the T final. And this is T initial. Okay, so you can take out all the information given. Okay, and then you can use equation. Okay, the change in area. Okay, delta A is equal to A naught beta times delta D. Where remember, beta should be 2 times the value of the linear expansion, which is 2 times alpha. Alright, so now, okay, A final. Okay, minus A initial. Okay, and this is the delta A. And then, ataupun kita letak A naught lah. Boleh juga. Okay, A initial. A initial. A initial kita dah tahu kan tadi. Nanti kita masukkan saja nilai dia lah. Beta is 2 alpha. And then delta T is T final minus T initial. So, T final tu yang kita nak cari. Finally, T final, we can write that A final minus A initial over A initial times 2 alpha, okay, and then plus T initial. So, semua nilai tu kalau kita dah ada, kita boleh masukkan teruslah. Okay, sentimeter tu kenapa kalau kita tak tukar unit pun tak apa? Sebab kat sini unit dia adalah centimeter squared. Kat bawah ini pun dia ada centimeter squared. So, nanti dia potong saja unit tu. Jadi, kalau kita nak tukar dia punya unit pun tak ada masalah. Kalau kita nak tukar pada meter squared pun tak ada masalah. Kalau tak tukar pun tak apalah. Okay. So, A final tadi adalah 30.2. So, delta A dia adalah 30.2. So, let's write that final area is 30.2 minus A naught is 30. Okay. And then over, that one is 30 times 2 alpha. Okay, so alpha is 24 exponent negative 6. Okay. And then plus T initial. So initial temperature, if you use degree Celsius, then T final here should be in degree Celsius, which is equal to 173.9 degrees Celsius. Okay. So this is the answer for question 7C. So let's proceed to the last question, which is question number 8. Alright, so now let's discuss question 8A. So the molecules of an ideal gas have a root mean square speed. So let's take out the information given. Okay, so we're going to have VRMS 1304 meter per second at temperature T is equal to 0 degrees Celsius. So if you change to Kelvin, so plus 273.15. So temperature is 273.15 Kelvin. Okay. So at the temperature of 20 degrees Celsius, so this is T initial. So T final is 20 plus 273.15 means that that one is 293.15 Kelvin. So T final. Okay. So calculate the root mean square speed. So we want to calculate what is the VRMS. final. Okay. Alright. So before we start, okay, so the question gives us the information about VRMS. So I call it as VRMS initial. Alright. So VRMS initial. Okay. So if we write the equation, VRMS is equal to square root 3 RT over M. So if VRMS initial is given and then T initial is also given, actually we can find what is the molar mass. Okay, so we can find what is the molar mass of the gas. Sebab soalan tak bagi dia punya molar mass kat sini. Okay, so now let's try. So VRMS is 1304. Okay, square root 3, R is 8.31, and then T initial is 273.15. Okay, and then the molar mass is M. So now let's try to calculate the molar mass first. Okay, so the molar mass is equal to 0.004 kg per mole. Alright, so now we can calculate what is the VRMS final. Okay, so molar mass tu mesti molar mass yang sama lah sebab dia masih gas yang sama kan. So VRMS equal to square root 3 8.31. So T final is 293.15 over the molar mass 0.004. So finally, okay, VRMS is equal to 1351.7 meter per second. So this is the answer for A1. So now we want to calculate the translational kinetic energy of the gas molecule. So this is very easy. We can just use equation of the translational energy of the gas molecule. Okay, so translational energy for a molecule is 3 over 2 kT. Okay, and then K is 1.38 times 10 power of negative 23, and the temperature is 293.15. Okay, so make sure you write the correct unit, 6.07 exponent negative 21 joule. Okay, so negative 21 joule. Alright, so this is the answer. So let's proceed to 8B. Alright, a 0.2 meter cube ideal monoatomic gas is heated from negative 60 degrees Celsius to 20 degrees Celsius at a constant pressure. So make sure you change this one to ATM. Make sure you change to Pascal. Alright. So 1 ATM. So this one given. So nanti you check dekat depan lah, depan list of your formula. So 1 ATM is actually equal to 1.013 times 10 power of 5 Pascal. Tukar kepada Pascal ya. Alright. So causing the gas expand by. So expand by means that, okay, let's say the V initial is 0.2 meter cube. So V final is equal to 0.2 plus 0.1. So it is equal to 0.3 meter cube. Okay, itu maksud dia expand by 0.1 meter cube. Then the heat of 30 kilojoule is supplied to the gas at constant volume. Okay, so kalau kita tengok kita tuliskan dulu proses yang pertama adalah constant pressure, iaitu isobaric. Okay, iaitu constant pressure. And then what happened? Okay, T final, T initial is equal to negative 60 degrees Celsius. So negative 60 degrees Celsius you can change to Kelvin plus 273.15. Okay, and it is equal to that one is 213.15 Kelvin. Okay, sekejap saya tutup ni. Okay, and then T final is 20 degrees Celsius plus 273.15 and 293.15 Kelvin. Okay, then the second process, the heat of the T kilojoule is supplied to the gas at constant volume, which is isochoric process. Volume is constant. Okay, so calculate the work done by the gas. So in order to calculate the work done, which is the total work done by the gas. So dekat sini kita ada dua proses lah. Okay, proses pertama dan proses yang kedua. So kalau saya nak sketch graph, okay, PV graph, look at here. So pressure is in, okay, you can change to Pascal if you want. And this one should be the volume. Okay, so the volume, okay, is expand. Alright, so from here we consider 0.2 and this is 0.3. Okay, ataupun you nak jauh sikit pun boleh jugalah. This one is 0.2 and this is 0.3. Okay, dia just sketch sajalah. 0.2 and this is 0.3. And then how about the pressure? So the constant pressure, right? So here should be 2. Ini boleh lah. This one should be times 1.013 times 10 power of 5 Pascal. Okay. So kat sini boleh letak 2. So kalau kita sketchkan. So the process, let's say from A to B at constant pressure. Okay, sebab dia kata dia expand kan, A to B. And then what happened to the temperature? T initial 213. So kalau saya lukis the line of the temperature, so the temperature initial here on the green line. Okay, so T initial, kita boleh letaklah T is equal to T1, 213.15 Kelvin. And then here at point B, you can write T2 is 293.15 Kelvin. Alright? And then for the second process, which is isochoric process, means that from B to, let's say this is B, and B is to C. Okay? So heat added, okay? Remember, heat added. So temperature is increasing. So C somewhere here lah. Okay, kita letak kat situ C. So now question number 1, we want to calculate the work done by the gas. So W total, work done for process A to B plus work done from B to C. Jadi untuk isochoric process, always remember, okay, for isochoric process, okay, W is from B to C is equal to 0. So this one should be equal to 0. But for WAB, so we can calculate W from A to B, constant pressure. Remember, equation dah ada kat depan kan? You ada equation 72, 73, 74. Okay, kita akan guna equation 73, which is P times delta V. Okay, so this one, P times delta V plus 0. Okay, so pressure tadi kita dah tahu 2 atm, you tukarkan kepada Pascal. And then the volume is increasing. V final dia adalah 0.3 tolak 0.2. Kalau tambah kosong tadi tak payahlah. So finally W total is 2.03 times 10 power of 4 joule. Okay, so this is the answer. And then number 2, determine the change in internal energy of the gas. So delta U for the whole process ABC, so it's equal to delta UAB plus delta UBC. Okay, so kalau kita nak buat satu-satu pun boleh juga. Okay, maknanya kita cuba tengok dulu untuk AB, okay, iaitu isobaric, okay, constant pressure. Okay, so kita boleh kira lah untuk isobaric. Okay, kita ada change of the temperature. So delta UAB you boleh kira. Okay, so this is so this is monoatomic. So the degree of freedom F/2, 3/2 and RT. Ataupun kita tulis dululah equation dia. F/2 and R delta TAB. Kan? So dekat sini kita boleh kira dululah 3/2 and so the number of moles, dia tak bagikan NR delta T. Okay, so jangan risau. Bila tak ada the number of moles NRT, so NR delta T here, actually you can change to P delta V. Okay, remember this one P delta V. So when we substitute here, so 3/2. So pressure dia tadi berapa? So pressure dia adalah 2 atm. You tukar kepada Pascal, 1.013 times 10 power of 5. Okay. And then darab dengan delta V dia tadi lah. Sekejap iaitu 0.3 minus 0.2. Okay, so delta UAB you akan dapat. Okay, kita kira yang tu dululah. Okay, so delta UAB is 303.9 joule. And then kalau kita proceed kepada delta UBC, okay, tengok kat sini So delta UBC untuk proses B to C tadi adalah isochoric iaitu V constant. So you can use the first law of thermodynamics. Okay, so from this one, actually delta UBC is equal to QBC minus WBC. Jadi sebab soalan dah tahu ini adalah kita dah tahu ini adalah isochoric process, so work done WBC tadi adalah kosong kan. So now delta UBC is equal to QBC, di mana delta UBC soalan dah bagi tahu dah tadi. Okay, maknanya then the heat of 30 kilojoule is supplied to the gas at constant volume. So the heat here, QBC, is actually equal to 30 kilojoule. Okay, jadi sekarang kita dah dapat dua maklumat delta UAB dan juga delta UBC. So finally, we can calculate delta U for the whole process ABC is equal to delta UAB plus delta UBC, which is 303.9 plus 30 times 10 power of 3 joule. Okay, so finally the answer is equal to, oh jadi dekat sini saya salah kira tadi kat sini adalah sepatutnya that one is power of 5 here, saya kira power of 3. Okay, so here should be 3.039 kilojoule. Okay, samalah tadi times 10 power of 3. Okay, so this one should be 3.039 times 10 power of 3 so plus 30 exponent 3. Alright, and then finally the answer is 6.04 times 10 power of 4 joule. Alright, so this is the answer for delta UABC. Okay, so kalau nak senang untuk soalan ini, kalau boleh awak lukislah dulu. Okay, kita lukis dulu dia punya graph. So dekat sini boleh nampak tulis satu-satu proses apa. So bila you dah tahu ini proses yang kedua adalah isochoric, so kita tahu WBC untuk isochoric kosong kan. So kita boleh termasuklah. Jadi student kena tahulah ini apa yang kosong untuk proses tersebut. Kalau isobaric, kat constant P ni tak ada apa yang kosong lah, kita boleh kira. Okay, kita boleh kira dia punya W equal to P delta V. Alright, so finish for question set score A. Okay, Fizik. Alright, so saya ucapkan good luck untuk semua calon yang akan menduduki kertas Fizik 1 SP015. So semoga berjaya, jangan careless. So jawab betul-betul. All the best. Assalamualaikum. Bye-bye. Jumpa lagi.